So 25b lets us dive deeper into quadratics and actually use that quadratic formula that we talked about. So remember, a quadratic equation is of the form ax squared plus bx plus c, where a, b, and c, and it equals 0. This is what we're trying to solve. The a, b, and c are any real number. You always have to have that x squared term for it to be a quadratic. You may not have necessarily a bx or a c, but you'll definitely have that squared term. The quadratic formula says that you can solve the quadratic equation pretty easily. You're just going to take the opposite of b, plus or minus the square root of b squared minus 4ac. Now be careful with that. You have to get that b squared minus 4ac is a singular number before you try to take the square root. Don't try to take the square root of the pieces. It is the square root of that thing. And then you're going to divide that entire thing by 2a. Okay, so that is your quadratic formula. And let's talk about some of the things we have to be concerned about. Do you see this one here? See where it says exact answer? That means that Alex wants fractions. Alex wants square roots. That's the kind of answer I want, the exact answer, 99% of the time. So when I show you this first example, that's the thing I'm looking for. Okay, so I'm going to write it a little bigger over here on the side, just so we have enough room, and just so we can really dive into this problem. So we know this is a quadratic because it has that x squared term. So you're always looking for that when diving into a quadratic. In this particular quadratic, the coefficient on your x is your a. The coefficient on your x squared is your a. The coefficient on your x is your b. The coefficient, well, not the coefficient, just the constant term that's on the end without an x is your c. Now, if there's any pluses or minuses, those go along with it. Now, when we go to plug those into our quadratic formula, I'm going to show you some tricks so that you will be less likely to screw up that order of operations. So let me show you my tricks. So when I plug in b, this first piece right here, think of that as immediately writing down the opposite of b. So b is 3, I'm going to write down -3, then my plus or minus. The next thing I'm going to do in my head, most of these numbers you can do in your head. If not, you have a big box of calculators on the back table. I am going to physically do b squared. Why take the time to actually write that down? I can do 3 squared, 9, and I write that down. The next thing you want to do in your head or on a calculator, see this part here? -4ac. You want to physically do -4 times a times c. So I would suggest in your head doing what is -4 times the a value of 6 times the c value of -1. And if it's a positive, you're going to put a plus down. If it's a minus value, you're going to put a negative down. And so that becomes a positive 24. All over 2a's, double A. You know how to double things very quickly in your brain. Don't put all this stuff into a calculator. 2a's, a is 6. What's 2 of them? 12, right? Yeah, just 6 times 2. Just double that 6, okay? Okay. Now you can see that it looks a lot nicer. Be careful. This thing here, you want to physically get a number before you do anything else. So you're going to get -3 plus or minus the square root of 33 all over 12. Now, here's where, see where it says apply in the quadratic formula exact answers. That is the exact answer. In Alex, be careful. You may want to put the top thing in parentheses, and I don't know if there is a plus minus button in Alex. So if there isn't a plus minus button, what you might have to put down is negative 3 plus the square root of 33 over 12. Negative 3 minus the square root of 33 over 12. So you know how Alex says to separate the solutions with commas? So one solution is where you keep a plus between them. The other one is where you keep a minus between them. Okay, so that is our first one, using the quadratic formula with an exact answer. Do we have any questions about that first one? Making sense a little bit so far. Okay. Now, let's talk about this next one. Now, Alex will give you the name of what you're doing. Use that name to give you a little heads up as to what might happen first. Do you see how this quadratic says the x squared plus the x, and then the number equals 0? Well, this one sure doesn't. So what we're going to do is we're going to do a little bit of algebra to this, make it look like that one, so then we can use the quadratic formula. Okay, so I don't have a lot of room here, but this is what I'm going to do first. I'm going to square that. I'm going to square that piece, okay? So remember, that's really w minus 7 times w minus 7. You might want to write it twice like that, so then you don't screw up the algebra, okay? Because you got to FOIL it. There's going to be that 4 pieces, and if you do that foiling in that 4 pieces, I haven't touched the left side yet, but the right side's going to say w squared minus 14w, because you're going to get a negative 7 and a negative 7 w's, and then plus 49. So if we were to take w, distribute it, negative 7, distribute it, and combine like terms, just so that I have enough room, that's what we're going to get. Okay. Now we're almost getting closer to looking like this, but only if we have the a, the x squared, then the x, then the number equals 0. So let's subtract all those to the other side. To subtract is to add the opposite. So let's just take this junk and make it the opposite on the other side. Okay. So what do I mean? Well, my 2w squared minus 10w plus 28, I am going to have to subtract a w squared, add a 14w, and subtract 49. Okay, so look what I did. This one became a negative w squared. This one became a plus 14w. This one became a negative 49. So I just moved them to the other side, changing their sign, subtracting them. Okay. And when we do that, we get w squared plus 4w. What would that be? That would be 21. Yeah, I think that's negative 21. Okay. Now we have the squared term, so we can find our a. We have the regular w term, so we can find our b. We have the number, so we can find our c. It always has to equal 0 before we do this next step. So in this next step, we find our a is 1, our b is 4, our c is negative 21. Okay. I know there's an easier way, but let's just now practice using the quadratic form, and I will talk about that in a second. There are lots of ways to solve a quadratic, and so, if you know an alternative that's going to work, main ways. You can graph it, you can factor it, you can use the quadratic formula, you can complete the square. Some ways lend themselves easier to others. That's a factorable quantity. I would factor it. We'll get to that. Okay, so let's apply the quadratic formula, and then maybe I'll show you the factorization just to show everybody what we're thinking. Okay, so that's what we got. Let's apply the formula. So it's going to be the opposite of b plus or minus the square root of. Now, do b squared in your head. 4 squared is 16. Now we're going to do negative 4 times A times C. Now, if you want to pull out a calculator for that, go for it. But 2 negatives make a plus. 4 times 21 is 84. And then 2 A's. A is 1, double it in your head, get 2. So I wouldn't put down every piece of that formula. Just do some of it in your head or in a calculator. And you get negative 4 plus or minus the square root of 100 over 2, which is negative 4 plus or minus 10 over 2. Now, this one actually says if there's more than one solution, separate them by commas. So this one, I'm wondering if maybe they're going to have that plus or minus symbol in there. I don't know. But this one, they definitely will not. So let's think about, what does negative 4 plus or minus 10 mean? Our two solutions are negative 4 plus 10, all divided by 2. Be careful of that. Negative 4 minus 10, all divided by 2. So we have to get an answer on the top. You may recall, please excuse my dear Aunt Sally, the first P stands for parentheses, but not really. It also stands for grouping symbols. And that division bar groups the numerator and the denominator as two separate things. So you got to do those first. So negative 4 plus 10 is 6. 6 divided by 2 gives us an answer of 3. Negative 4 minus 10 is negative 14. Divided by 2 gives us an answer of negative 7. So our answers that we would give to Alex would be 3, negative 7. Now, someone noted there's an easier way to do this problem. There is. Okay, let's talk about that real quick. Let's go back to this version. If a quadratic is factorable, that's the easiest way to solve it. Let me say that again. If a quadratic is factorable, that's the easiest way. It's always the easiest way. But if you're not good at factoring, you can always use a quadratic formula. If you're not good at factoring, you can always graph it. But this is a factorable quantity. That factors to be w plus 7 and w minus 3 equals 0. Oh my gosh, the 3 and the negative 7 appeared. Do you see how they end up being the opposite in the signs? The answer was negative 7 and positive 3. Now the reason that is if we solve that, when we move the 3 to the other side, what happens to the sign? It flips the sign. And so this gives me the exact same answer as that. So a factorable quantity is the easiest way to solve any quadratic. If they ask you to do it a particular way, Alex isn't going to know that. If I ask you to do it a particular way, and I don't, sometimes I'll give you one that I'll say, hey, do that the quadratic formula. I'll say one, do that by factoring. And then the rest I might go, hey, do it whatever way you want, okay? So just so that I can kind of test that you are understanding how to do each particular method. So do we have any questions? Are we good so far? Okay, now let's take a look at this one. So this one says, find the roots of a quadratic with leading coefficient of 1. All that means is this one here is a 1. Now, I will tell you, I always look for a way to factor it. The easiest way to solve a quadratic is to factor it. If I don't think it's factorable, then I go to the quadratic formula. I like completing a square. I think it's a cool method, but it's the hardest method and it's the most complicated. I wouldn't complete the square if I didn't have to. I'll show it to you. There is some applications to calculus, but it's not super important. One or the other. Factor it or use the quadratic formula. So when we look at this thing here, I think they didn't specify use the quadratic formula. They didn't tell me it's factorable. I'm going to factor it. So let's do that. When I say to factor it, I mean, and I'll kind of zoom in so you can see a little better here. I mean that thing can go into two pieces. I can unfoil it. I can break it into two binomials, okay? So I need the factors of 7 that have a difference of 6. The only factors of 7 are 7 and 1. If the back sign is negative, I'm going to subtract those to get the middle. 7 minus 1 is 6. Yay. If this was a plus, that would have to be an 8 in the middle for it to be factorable. Hopefully that made sense. But your final factorization is x plus 7 and x minus 1. Now let's talk about the signs here. It is a plus 7 because we're going to subtract these two. We need the bigger number to match the middle. So if the back sign is negative, you know you have a plus minus, but the bigger number should always match the sign of the middle. So our bigger number is 7. It needs to be a positive. So when we do that subtraction, it will match the middle. Does that make sense how that works? So be careful. And you can always, how do you check factoring? Multiply it back out. Should I get what this is? Now, what's great, in the 2-5A homework, you had some that were already split up. See, Mrs. Hott was thinking ahead. And she thought, hey, if you see the ones that are already split up and how easy it is to solve them, you just split them apart one more time. This is the best way. So here we go. Let's do one. So you're going to set x plus 7 equal to 0. You're going to set x minus 1 equals to 0. And that's that zero product property of two things multiplied together to give you an answer of 0. The first thing can be the thing that caused the 0, or the second thing can be the thing that caused the 0. So you can split it apart, solve it very easily. Here you'll notice that the x changed sign. When you subtract it to the other side, it becomes a negative 7. Here we have to add 1. It goes to the other side and changes sign. You got to get used to that. That's going to be very useful. There's some things we do with graphing that switch over is going to happen again and again for many applications. So when you give your answers to Alex, you're going to put in negative 7 and 1 separated by commas. Does anyone have any questions about that one? Okay. Now, I want to talk about this one. A few different things are wrong with this one. And it's not necessarily that they're wrong. But when I initially gave you the quadratic equation, I said it was ax squared plus bx plus c equals 0. That allows us to apply the formula. What do you see that's wrong with this problem right now? Tell me. So what could we do to make it equal to 0? Add 25 to both sides. So let's take that and scooch that over, okay? So if we add 25 to both sides, we get 9u squared plus 30u plus 25 equals 0. Okay. Now it is a candidate for the quadratic formula. Your A is 9, your B is 30, your C is 25. But it's also a factorable quantity, okay? So let's factor it. I think factoring is always the easiest way to go. But I'm going to show you a technique that I call slide and divide. Now, if you already see and know how to factor it, some schools do like an asterisk method and these other methods. They're all well and good, but I think I've taught algebra of some sort for 30 years, and the best way I've ever seen is this slide and divide method. And kids struggle with factoring. It's just a struggle. It's always easier to multiply quantities than to pull them apart and divide them. So it's just natural that it's harder. So I'm going to show you slide and divide, but if you already know a method and you already know the answer, you go for it. But I'm going to show you my method, okay? Okay, I'm going to take this 9. I'm going to slide it over and multiply it by the 25. 9 times 25 is 225. Okay, so I'm going to pretend like they gave me this. Now, I'm not doing the 0 there. I'm just factoring it, okay? So I'm going to take the 9. I'm going to slide it over, slide and divide. I'm going to slide it and multiply it by that back number. 25 times 9 is 225. Okay. And then I'm going to factor it. Well, what are the factors of 225 that might add up to 30? Well, 225 is 15 times 15. Doesn't that add up to 30? That's what I want, right? And so this is going to be u plus 15 and u plus 15. Now, what did I slide over? The 9. This method is called slide and divide. So I slid, did the math. Now I got to divide, slide and divide. And so I'm going to divide by 9. Okay. You want to reduce that fraction as much as possible. So what are both the top and the bottom divisible by? 3. So make that 5/3. And to make it match the quantity over here, slide and divide. We divide, but did you see any fractions over here? No. So to fix the problem, just take the little 3 and put it on the u. So this answer really was 3u plus 5 times 3u plus 5. So we factored it. Slide and divide. I just like the method. It works every single time. It actually has elements of all those other methods, the guess and check and the asterisk method and all those other. It's in there. It's just a little more clear what you're doing. Okay, so let me show you what I did one more time. Take the 9, slide it over, multiply it by what was on the back. 25 times 9 is 225. What are the factors of 225 that make 30? 15 and 15. Break it apart. But I slid over 9. Now I have to divide by 9. Reduce that fraction. If it's reducible, you're done. If completely reducible, you're done. If it ends up still having a denominator, just stick the denominator on the u and then you're done. Okay? Now, since they match, this only has one solution. So you only got to do the math once. So 3u plus 5 equals 0 is going to give us the same thing if we just left it like this for future reference. And you get 3u equals -5 and u equals -5/3. Let's look what happens every single time. This changes sign and we divide by the coefficient on u. So it's -5, that one changes sign, and then you divide by the coefficient 3. So -5/3. So that is my only solution. And when we go to graph ones like this, when you get two of the same solution, it just tells us that our quadratic hits the x-axis perfectly in one location and kind of bounces off the x-axis when that happens. So, so think about if a parabola goes through the x-axis, you get two solutions. But if a parabola bounces off the x-axis, you only get one. And so if you were to graph this parabola on like Desmos, you would see that it only hits the x-axis at one spot. It kind of bounces like a bouncy ball bouncing off the floor. Okay, so that is all that I can tell you about the more complicated quadratics at this time. So now let's go ahead and look at your final homework for the week, okay? So let's go down here to 2.5b. You can even write a little thing. This is 2.5b. And it says in these first ones, these first four, to solve by factoring. So don't forget to get it equal to 0, and then you should be able to factor it, okay? And then these ones say to use the quadratic formula. And when I did these, I must have cut these off. So just cross those ones out. We just can't. So just cross those out. And so you just have 4 that are factoring and 4 that are the quadratic formula, okay? You can check your work if the bottom ones are factorable. You know, that's a way to check what you're doing. You can, even if you get stuck on the factoring, flip-flop and try one of the top ones with a quadratic formula. I'm okay with that. But try to do the method they've asked. Does anybody have any questions? Anybody have any questions at this time? So go ahead and work on this assignment. We are going to have class time tomorrow to kind of finish anything up. Ask me questions if we go. Work on Alex. Remember, you're going to have 3 assignments due Friday at midnight, 2-4, 2-5A, 2-5B, and then Alex is not due until Sunday. So there you go.